Hey guys, it's Mrs. Spears. I'm on lesson 11.1 and today is Monday, May 18th. The section is called Investigate Angles and Fractional Parts of a Circle. So this lesson, the goal of it is to try to help you connect how angles work to fraction pieces, which is something you guys are super familiar with stuff that we've done in the past. So this lesson involved me having to use both my hands. So I couldn't hold the camera with one hand like I normally do when I make my videos. So unfortunately, this was kind of the best I could come up with. So you only see like part of the frame has the book in it, but this is kind of the best I could do. So hopefully this works today, and we'll see how it goes. So for this investigate activity, it wants you to use fraction pieces, which I'm guessing if you're like me, I didn't have those at home right now. So I'm kind of making do with the best that I can based on what I've got around the house. So it says you need fraction circles, but place a 1/12 piece on the circle. Place the tip of the fraction piece at the center of the circle and trace the fraction piece to create an angle. So since I don't have fraction pieces at home, I'm going to make my own just real quickly. So I took the big circle that they have me draw on down here, and I traced it with a piece of paper. It's not perfect, but it'll work. And then I traced the dot, and then I cut it out. So what I'm going to do next, I'm going to fold this circle in half. Oops, sort of. Best I can. So that's a half-size circle piece. I'm going to fold it in half again and make 1/4 size pieces. Okay, so there's my 1/4 size piece. I can't fold it in half again, or I'm going to make 1/8 sizes, and I need 12 sizes. So I kind of have, this one's kind of weird, but I'm going to try to fold it like an envelope, but in thirds. So like you fold not an envelope, but a piece of paper that goes into an envelope gets folded into thirds. So I'm going to kind of do that with this. Just the best that you can. Doesn't have to be perfect. Like I said, you don't have to do this part at home. You can just watch along with me if you want, but if you want to do it with me, you can too. So if I open this back up, I will have 12 sections in it, if I did it right. Yep, and I do. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I am actually going to cut out one of these 12 size pieces to represent the picture that they want me to have over here. Okay, so now I've got a 1/12 size piece, just like I would have at school. So I'm going to color it orange so it sticks out just a little bit on camera, but this part was optional. So this is 1/12. Okay, so then it says, if I go back to the directions, it says put the 1/12 piece on the circle. So I'm going to do that. It's on my circle. I'm going to match the point up with the point from there. So it kind of lines up. It works pretty well. Trace the fraction piece to create an angle. So I'm going to hold it down. Take my pencil, which is looking kind of funky right now. There we go. And I'm going to trace. So I'm going to move this up a little bit so you can see some more. There we go. Okay, so that's 1/12 of the circle. There. So it says, what parts of the fraction piece represent the rays of the angle? So that's this question right here. The parts of the fraction piece that represent the rays of the angle. So here's your angle. That's the sides. The sides of the fraction piece represent the rays of the angle, the lines part. And it says, where is the vertex of the angle? The vertex, remember, is the joining point of an angle. So the vertex is the middle of the circle. So the middle point of the circle. Alrighty. So it says shade the angle formed by the 1/12 piece and label it 1/12. So that's 1/12 on here. There. Place the 1/12 piece back on the shaded angle and turn it counterclockwise. Now, when it's talking about counterclockwise and clockwise, it's going to talk about that a lot in this lesson. Counterclockwise is the direction opposite from the way that the hands move on a clock. So if you've got a normal clock like this, so I'm going to just draw in some of the numbers. Oops, sorry, 6, 9. Normal clocks go this way. Okay, they start at the 12 and they go around this direction and go that way. Counterclockwise goes the opposite direction. So I'm going to take this little piece and I'm going to turn it the opposite way. Okay, turn it counterclockwise. So I'm going to leave the same point on here. Make sure you can see. Leave the same point on here and I'm going to turn it counterclockwise like this. Okay, and then I'm going to trace it. Trace the fraction piece in its new position, it says. So I'm going to. How many twelfths have you traced in all? There's 1/12 plus another 12th makes it 2 twelfths that we've done so far. And then it says turn the fraction piece counterclockwise again and trace it. So I'm going this way. If I were going clockwise, I would be going this way. But I'm going, it says to go counterclockwise, so I'm going to go this way. So I'm going to trace it again. That's another 12th size piece. Label the total number of twelfths, which would be 3. Continue until you reach the shaded angle. So I'm going to go all the way around. So far we've got 3, 4, 5, and it's not perfect, and that's okay. 6, 7, 8, 9, whoops, 9, there we go, 10, 11, and then the 12th one is just a little bit bigger. That's because it's not perfect, and that's okay. You get the general idea, though, from it, and that's what matters. So how many times did you need to turn the 1/12 piece to make a circle? I needed to turn it 12 times to make an entire circle. How many angles come together in the center of the circle? Because I have 12 pieces, I've got 12 angles inside this circle. All right, turn the page. I'm on page 602 now. So, I'm going to do these questions with you, and then I'll turn the camera back to where it normally is. It says, compare the size of the angle formed by a 1/4 size piece. So I'm going to go back to my scrap that I had from my thing, and I'm going to cut out a 1/4 size piece, which I know 3 twelfths fit into a 1/4. So I'm going to cut this off so I can use it as a comparison. Okay, and I'm going to shade that in blue so that you can see the difference. So this is 1/4. Okay, so it says compare the size of the angle formed by a 1/4 piece. Here's my angle right here, and the size of the angle from a 1/12 sized piece. So there's my angle on this one. Use a 1/4 piece and your model on page 601 to help. So we're comparing these guys. I know that 3 twelfths can fit into a 1/4 size piece, which means that 3 12th size angles fit into one 1/4 size angle. So I can add this angle together, plus this angle, plus this angle, and get a 1/4 size angle, which 3 are the 12ths, which we know that the equivalent fractions, 1/4 equals 3/12 are equivalent fractions. So that's where that comes from. Describe the relationship between the size of the fraction piece and the number of turns it takes to make a circle. So basically we know that the smaller the piece is, the more there are to make up a whole circle. Same thing this one, the bigger the piece is, the less pieces you need to make a whole circle. So it says, when it says describe the relationship between the two fraction pieces, the smaller your size, the smaller your angle, the more angles will fit into a circle. The bigger your angle, the less angles that will fit into a circle, which is the same thing as we know from using fraction pieces. Alrighty, I'm going to turn the camera around, so it's going to look kind of funky for a second here. Oh, you can see my messy desk. Oh, there's my wall. If I can flip the camera around. Nope, it won't let me flip the camera around because it's already in one spot. Oh well, no big deal. I'm just going to hold it weird today. That's okay. It's worth it. Okay, so I'm still on page 602. Sorry about that, guys. It says, you can relate fractions and angles to the hands of a clock. Let the hands of the clock represent the rays of an angle. So here's your hands of the clock, and they represent the rays. Each 5-minute mark represents a 1/12 turn clockwise. So all of those 1/12 size pieces, like this, represented a one number change on a clock. So if you look over here at this picture, it's got from the 12 to the 1, that's a 12th of that whole circle. Because we know that there are, if you do 5 times 12, then you get 60 minutes. So that's how we break that up. So clockwise, it goes this way. So follow the arrows. They'll tell you what to do. Clockwise, 3 places over means 15 minutes have elapsed. The minute hand makes a 1/4 turn clockwise because it's 1/4 of the circle filled in, and it turned 1/4 of the way around. It would be like if I had taken this 1/4 size piece, put it in my circle from before, and turned it around one whole time. It made a 1/4 size turn. 30 minutes have elapsed. The minute hand makes a half turn clockwise because it's a half of the clock. 45 minutes have elapsed. So I've gone 15 minutes, that's 1/4, another 15 minutes, that's half, and another 15 minutes would be 3/4 of a turn clockwise. Oops, sorry. There you go. 3/4 of a turn clockwise. And then 60 minutes have elapsed. So I have 1, 2, 3, 4 turns. So that's 4 out of 4 possible ones, which means it makes one whole turn clockwise. So that's why sometimes you'll hear somebody say, oh, it's 1:15. Well, that means it's 15 minutes. It's 1:15 because it's gone 1/4 of a turn around the clock. So that would be 15 minutes. You can see half past, 1/4 till means there's 1/4 of an hour left until we get there. So that's where those terms come from when people say stuff like that. Okay, so this one says, tell what fraction of the circle is the shaded angle represents. So this is just practicing how many turns it went through. But you can use what you know about fractions to figure this out. So from here to here, that's half of the circle. From here to here, even though we didn't start up here, it's okay. It's still only gone 1/4 of a circle. From here to here is 3/4 of a circle because there's 1, 2, 3 of those in there. This one went all the way around, so that's one whole. This one's still just half, okay? Because only half a circle. Again, it starts in a weird place, but that's okay. It doesn't matter. What matters is how far has it gone. And then this one looks like it goes from like 12 o'clock to 1 o'clock. That would be just like the 1/12 size piece that we already have. So this is a 1/12 size turn. Tell whether the angle on the circle shows a 1/4, 1/2, 3/4, or 1 full turn clockwise or counterclockwise. So first, I like to just go through and say which direction is it going. So this one is going this way, which means clocks go this way. So this is going the opposite way of a clock, which means this is counterclockwise. but it only went 1/4 of the way around. It'd be like shading it 1/4, just like one of these problems up here. So it made a 1/4 turn counterclockwise. It went this way. This one made a half size turn because it's half a way around clockwise because the arrow is going this way. So that's clockwise, 1/2 turn. This one started here and went all the way around this way. And then because it's going this way, it's going like a normal clock would. That means it's clockwise, 3/4 of a turn. It's 3/4 of the circle has gone by. All right, Susan watched the game from 1 p.m. to 1:30 p.m. Describe the turn the minute hand made. So they show you in the clocks over there. She was at the game from 1 o'clock to 1:30. So she went a half an hour or half a turn. Describe the turn. So it's a 1/2 turn. And because we're actually measuring in time, we're talking about time. We're not going backwards in time. She's going forwards in time. We can say that she went clockwise. So it's a 1/2 turn clockwise. Compare the angles in exercise 1 and 5. Does the position of the angle affect the size of the angle? So it wants you to go back and look at number 1 and number 5. So compare these two. And this one, the position of the angle does not affect the size. This is still half a circle covered. This is also a half a circle covered. It's just this one started in a weird place compared to this one. It's okay. It doesn't matter. So does the position affect the size of the angle? No, it does not. Because the same amount of space has been covered, returned. Depends on how you look at it. All right, turn the page. So I'm on page 604 now. It says, Malcolm drew this angle on the circle. Oops, can't see it, sorry. There you go, guys. Right, this one right here. Malcolm drew this angle on the circle. Which of the following describes the angle? Mark all that apply. So this one goes the opposite direction of a clock, as a clock goes the other way. So that means it's counterclockwise. And it went from here all the way around to here, which is 3/4 of a turn. Okay. All right, so this one, I'm just going to kind of talk you through this one real quick. It says, whose statement makes sense, whose statement is nonsense, and explain your reasoning. So Carla says that in this picture right here, 1/4 of the circle is represented here. That's a shaded angle. Adam says that the shaded angle represents 3/8 of the circle. So this one, 3/8 is really close to 1/2 because 1/2 of 8 is 4. This doesn't even come close to shading in half of the circle. So Carla's statement is correct because it's the closest measurement. It's about a 1/4 of the way around. It'd be like going 15 minutes on a clock. Adam's is not because his answer is really close to half, and that is not close to half. All right, guys, so here's your assignment for today. It's this next page. This is page 605. If you join me for Zoom today, like today said, today is May 18th. If you join me for Zoom at 1:30, I'll go over this page with you. If not, you can send me any questions that you have online, and I will see you in the next video. Bye!